All right, there's a few seats left. If you want to fill them in, that'd be great. Let me, on behalf of General Atomics and the U.S. ITER Project Office and Oak Ridge National Lab, welcome you today to this celebration marking the shipment of the first two ITER central solenoid modules to France. This is a culmination of about 10 years work of effort here at General Atomics in conjunction with the U.S. ITER Project Office and the international community to produce the ITER central solenoid modules, often known as the heart of ITER. As you may or may not know, the first module has already actually arrived in France and has been offloaded from the ship. And the second one, right here behind me, is leaving this week via truck to Houston, and will get on a ship and be on its way to France here. All total, there'll be seven of these modules that will be shipped. 6 of them will be assembled into ITER, and the 7th one serves as a spare. ITER project holds the promise of clean, limitless energy for the world. The project is comprised of 7 parties and 35 nations. It is the largest scientific experiment ever built. The progress on ITER has been quite amazing. We're now about 75% complete on the assembly, and it's an impressive facility. You'll see some pictures of it later on this morning and some videos. The central solenoid that we're celebrating today is the largest contribution for the U.S. When fully assembled, the 6 modules stacked together are almost 60 feet tall and weigh 1,000 tons. It is one of the last components that will be assembled into the ITER center of the ITER tokamak. The incredible team here at General Atomics has designed and built the 10 purpose stations that you'll see around the facility today, and you'll see some video about that and all of these are necessary to fabricate a module. Japan, as part of their contribution, has delivered about 42 kilometers of the steel-jacketed superconductor that you see is the large piece on the side over here. If you can imagine, 42 kilometers of this is no small feat to produce that itself. So we carefully wind that conductor in 6 kilometers of it into each of the modules, and then we heat treat it, provide insulation around it to insulate the turns, and then do a resin injection that makes it one monolithic structure. Afterwards, we perform a full battery of tests, including a simulation of its operation in ITER. So when the coils arrive in France, we know they're going to operate and we'll be successful. The manufacturing process for each one of these coils is about 2 years. And then we perform about 4 to 5 months of testing. All in all, it's no small feat to complete the module you see here today. We see 2 of the other modules behind me in their various states of manufacturing in progress. We'll show you a little video later of all this manufacturing process. This project has been and continues to be a complete team effort. First and foremost has been the General Atomics team, most of which are here today. But it includes staff from facilities, of our purchasing group, our contracts group, safety, and most importantly, quality assurance. But at this point, I'd like to take the opportunity to introduce Neil Blue to you to say a few remarks about the project. Neil?
Thank you, John. A very comprehensive introduction to the purpose of the ITER project. Fundamentally, I would like to say that you're all very welcome here to celebrate what is a seminal achievement in the quest of developing economically practical fusion power. And fusion power, of course, was demonstrated in more than a bench scale basis when the first hydrogen bomb was ignited. The issue was a matter of how do you contain and sustain this amount of energy for the purpose of generating practical nuclear power based upon a fuel source which is virtually unlimited. And it is a result of the enormous collective support and cooperation of the Department of Energy and of the Congress of the United States and of the gentlemen and ladies represented here who have participated so very materially in developing what is the milestone we celebrate today. I would like in particular to recognize the presence of our distinguished representative, Ken Calvert, right here, from whom you may hear later, and Daryl Issa. And we have Todd Gloria, the mayor of San Diego, right here in attendance in a recognition of the importance of this occasion. It was about 10 years ago, as John suggested, that General Atomics embarked upon and was assigned the task of designing, engineering, producing, and delivering the solenoid, the central solenoid for the ITER project. This project was a formidable task, appropriate for a General Atomics organization in the sense that it aspired to build the most powerful superconducting electromagnet ever produced in the world. And indeed, that project, as you will see, has an enormous scope in terms of its size. The size amounts to about a 5-story building made of these solenoid components, and it will weigh about 1,000 tons and deliver 15 million amperes of power to the plasma at the central part of the reactor. That's quite an extraordinary ambition, and we celebrate today the fact that we're actually delivering this equipment, which will contribute to making the international cooperation or collaboration of ITER practical in demonstrating a continuous burning plasma materially advanced from the General Atomics National Fusion Center here, epitomized by the D3D reactor experiment. And so I'd like to say at this point that I'd like to recognize all of you here and the men and women of General Atomics who have been able to, with the support of the Department of Energy and the Congress, above all, in sustaining this effort, which will constitute one important step forward in the quest of achieving renewable nuclear energy based upon a virtually unlimited fuel supply. And so, with those abbreviated comments, John, I'd like to pass this on to you further. Thank you. All right, sir.
So General Atomics is extremely proud of the many collaborative partnerships that we've established, but particularly the ones in our nation's leaders in Washington, D.C., who represent our own region, in fact. I'm very pleased now to introduce Daryl Issa. Congressman Issa represents California, come on up, Congressman 50th District, which encompasses the central and northeastern parts of San Diego County, including the communities of San Marcos, Escondido, Santee, El Cajon, Temecula, and many others. Congressman Issa.
Thank you. You know, a politician is best if he doesn't try to be something he isn't. So I could come up here and I could talk about General Atomics and first of all disagree with John and say 10 years? You have no idea how long Lyndon has been talking to me about this kind of technology. It's 40 years. It's a lifetime of dedication that is in fact at the root of General Atomics. But I just want to put something in perspective, maybe not for the engineers and scientists here, but for people that may look at this later and say, why is this such a big thing? Every day, somebody of my level of technology understands that a small solenoid, some winding, starts your car when you push the button or turn the key. And we've been doing that for about 100+ years. One of the first experiments in electricity was really winding a little piece of conductive material and discovering that it could in fact move matter. Behind me are devices that could lift an aircraft carrier. It's not about scale, it's about life-changing, world-changing technology. So when I look at something that has taken what we all knew to be possible 100 years ago, which is the moving of a little bit of matter, and now takes it to moving matter to energy in a clean and permanent way that could change the future of our lives, but of billions of people who today cannot afford energy because this kind of clean, inexpensive energy doesn't exist. I'm excited. And I just want to take that moment, John, to disagree with you and to say to Neil and Lyndon and the whole team here, a lifetime of dedication is being celebrated here today. So thank you for what you've done. I'm glad that Congress has been a small part of it. Thank you.
Thank you, Congressman Issa, for the good reminder of what really a solenoid can do when we lose sight of these. You know, more than 80% of the funds appropriated by Congress for the ITER project are used domestically to support high-tech jobs and manufacturing in the United States for in-kind contributions like the Central Solenoid. This funding would not be possible without the strong support of the House and Senate committees on appropriations, which continue to support the investments in fusion with robust funding every year. We are incredibly privileged to have the support of key members of the United States Congress who understand the need to prioritize fusion energy and fusion research, including those that serve on key authorizing communities. With broad jurisdiction over defense-related federal research and development, including the Department of Energy, NSA, and the National Science Foundation, the Science, Space, and Technology Committees have been essential partners in charting the path towards fusion energy. Now, in these times of COVID, we'd like to have everybody here, and many of our representatives would like to have been here, but we're able to have some shared messages via video from them. And so at this point, I'd like to introduce a video for the representatives Eddie Bernice Johnson and Frank Lucas, the chair and ranking member of the House Science, Space, and Technology Committees.
Hello, I'm Congresswoman Eddie Bernice Johnson, chair of the House Committee on Science, Space, and Technology. Thank you for inviting me to participate in this important celebration. We are here to mark the delivery of the first Central Solenoid model to the ITER International Fusion Project. The Central Solenoid truly represents the heart of this groundbreaking experimental facility, and the team at General Atomics should be very proud of this accomplishment. Their historic achievement represents a major step toward ITER's completion and the ultimate realization of the promise of fusion energy. It is also a symbol of the U.S. commitment to this project and a tangible reflection of our desire to work with our international partners to develop a technology with the potential to develop clean, abundant energy to the world. We in Congress have been working diligently to further enable and equip the dedicated scientists and engineers building ITER and its components. In particular, I'd like to highlight my committee's long-standing support of the project. On the legislative front, I strongly advocated for the inclusion of comprehensive guidance and support for the U.S. fusion program in the Energy Act of 2020, which was signed into law late last year. This law includes the authorization of resources that are required to honor our international commitment to NETA and avert the significant financial, diplomatic, and scientific impacts of undermining its continued progress. More recently, the U.S. House of Representatives just passed by a very wide bipartisan margin the Department of Energy Science for the Future Act. This would be the first ever comprehensive authorization for DOE's Office of Science. This bill extends the authorization of investments required to maintain the schedule for the U.S. contribution to the ITER and minimize its total project cost. In addition, it authorizes new and expanded fusion energy research activities, including support for fusion materials R&D, fusion reactor system design activities, and for emerging innovative fusion energy concepts. Beyond legislation, our committee has worked closely with ITER's management team to ensure the success of the project. I'd like to commend ITER's leadership for their transparency with us in Congress, who oversees these investments, and for working closely with us to develop and implement a comprehensive and realistic schedule, the budget, and plan. This approach has underpinned ITER's ability to respond and adapt to the unanticipated issues, including the global COVID-19 pandemic, and to continue this vital work diligently. I am very pleased to hear that the construction of ITER is now nearly 75% complete. Still, our work is not yet finished. I remain committed to working closely with the Biden administration and with my colleagues in the House and Senate to ensure that the robust foundation we set for ITER and for the fusion research overall is implemented this year and well into the future. In closing, I'm delighted to have this opportunity to speak to you today, and I look forward to working with you to ensure the timely completion of this revolutionary endeavor, and thank you again.
I'd like to congratulate everyone who's worked so hard to complete the central solenoid module for the ITER reactor. This is a major milestone on the path to fusion energy. Fusion is the next great scientific frontier, with the potential to produce nearly limitless, zero-emission power for centuries. On the Science Committee, there is bipartisan agreement that we must make bold investments in the U.S. fusion industry. I have long been a strong supporter of fusion energy research. After visiting the ITER project in 2015, I was even more impressed by the size and the scope of this first-of-a-kind facility. I'm especially proud of the U.S. contributions to this project. While the ITER project is obviously being built overseas, over 80% of U.S. funding is spent right here at home, where it supports research and component fabrication in American universities, national labs, and industry. Today's achievement is a great reminder of that. Of course, I expect nothing less given the immense talent we have working on this project. The Department of Energy is a global leader in technology development and scientific innovation. Discoveries made through the department are the force behind the development of next-generation energy technologies. I want to congratulate General Atomics on this accomplishment, which is massive in more ways than one. I also want to commend Dr. Vigo and the ITER organization for their leadership. I look forward to hearing about the great progress that can be made together to deliver on the promise of safe, emissions-free, and nearly limitless energy.
And finally, we're pleased to have a short greeting from Congressman Scott Peters, whose district includes here Poway, where we're located today. Congressman Peters has been a great friend of General Atomics and the ITER project, a true advocate for fusion energy. He toured his facility just a few months ago and was excited to see our progress and talk with the staff. Here's Congressman Peters.
Hi, everyone. I'm Scott Peters, and I represent California's 52nd Congressional District in Congress, including the city of Poway, where, as you all know, General Atomics scientists have been hard at work to produce virtually limitless clean energy. Unfortunately, I can't be with you in person today, but I'm honored to join you in celebrating the shipment of the first module of the ITER Central Solenoid from my district in San Diego County to the International ITER Research Facility in France. It marks a historic feat as we continue to find and develop reliable, clean, sustainable energy for the world. I'm also so thrilled that GA is providing the largest U.S. contribution to this experiment, joining the 35 nations that form the ITER collaboration. The ITER program demonstrates the value of public investment in research and development and the importance of global collaboration. I have no doubt that fusion energy will play a significant role in battling the effects of climate change, building a more resilient grid, and developing the future of our innovation sectors. Back in April, I had a chance to see this superconducting magnet in person during a visit to the General Atomics Magnet Technology Center, and I was blown away by its power that will provide the unique forces needed to create fusion energy. The work I saw that day is a clear indication of the high-level innovation in my district and the devoted efforts to move away from our dependence on fossil fuels. Congratulations to all those involved, and we look forward to seeing all that is accomplished because of your work, as well as the Central Solenoid's first operation in 2025. I wish you the best of luck, and thanks.
We at General Atomics would like to thank all of our esteemed partners in the U.S. Congress who have been so supportive of the Central Solenoid project and of the ITER collaboration. We know that all projects of this scope and scale are not possible without the people who put in the time to do the research and complete the fabrication from start to finish. With each module taking more than 2 years to complete, it is the people in this room who made this accomplishment possible. It is truly remarkable that our region will have left such a significant mark on ITER when the first plasmas are produced in 2025. In fabricating the Central Solenoid and operating D3D, General Atomics, along with many of our local suppliers and partners in the San Diego region, has truly led the way in fusion energy and the international ITER collaboration. We are privileged today to be joined by Todd Gloria, who is currently serving his first term as mayor of the city of San Diego, where he has prioritized expanding the renewable energy footprint in our own region. Please join me in welcoming Mayor Gloria to say a few words.
Thank you for that introduction, John, and good morning, everyone. What an exciting day for our region. It's great to share it with you all. Thank you so much for the invitation to be here, as well as the hospitality. To Lyndon and to Neil, thank you for your leadership in our region over a long period of time. It's great and an honor to share today alongside Congressman Issa, Congressman Calvert, and my friend Congressman Scott Peters. I wanted to be here because this truly is an important milestone for the world, but particularly here in San Diego. You know, I'm really proud of helping to lead a city that is at the forefront of technological advancement in the clean energy space. I tell you, there's a lot of mayors in this country, but not all of them can say what we can say here because of the work that you all are doing. The fact that the heart of this multinational scientific collaboration, the Central Solenoid, is manufactured here in San Diego is something that we can all be incredibly proud of. The world's, and I just think, let's drive that home. There's a few reporters who are here. The world's most powerful pulsed superconducting electromagnet was made right here in our own backyard. That's exceptional. That's some big city stuff, and that's why I wanted to be here to celebrate it with all of you. The local EDC would ask me to remind you all that this demonstrates the strength and the resilience of our cutting-edge technology industry here in the San Diego region. And that's really the result of a collaboration that has been the hallmark of San Diego for a very long time. We have all the ingredients for a successful technology cluster. And I'm not just talking about the climate, although it's pretty unbeatable, as the congressman will certainly know, having to work in far worse climates when you're in the Capitol. I will tell you that in addition to our beautiful natural resources, we have a top-notch set of talent pool that is directly pipelined from our top-notch national universities that are located right here, along with some of the hardest working people that you'd ever meet. And I see that those are all the folks that are holding up the wall in the back. But to the men and women of General Atomics, I want you to know that how proud I am of your contributions to this incredible effort. You know, what you do is incredible, absolutely incredible, in bringing true pride to our city and to our region. And I'm proud that you'll be able to say for the rest of the time, as this comes together and we bring transformational change, not in San Diego, not in the United States, but around the entire world, that you help be a part of that. That you can tell your kids and your grandkids that mom or dad built that. I think that's exceptional. I think that's exciting. And as mayor, I want to do everything I can to continue to make sure that manufacturing of this quality and of this caliber can continue to happen here. Many of you know that our city has set ambitious climate action plan goals. We have a vision of running our city on 100% renewable energy by the year 2035. What you all are doing here at General Atomics will help make that objective real. And when we do it here in San Diego, others have followed our lead. And so this is an exceptional day. This is a good day for our city and for this industry, but as been mentioned by so many others already, this is important for our planet. And I just thank General Atomics for the work that they do in leading us to a cleaner future for all of us. And I thank everyone who's been involved in this exciting development. And lastly, I would just wrap up by saying, you know, we're the 8th largest city in the country. Sometimes that goes overlooked. In fact, when I served in the legislature, I'll tell you, most of my colleagues thought San Francisco was the 2nd largest city in California, when in fact it is our great city. And it's days like today, accomplishments like this one, collaborations like we're talking about today, that really signifies that we are a big global city capable of competing with any other city on the face of this planet. And I believe that when we compete, we will win. Thank you for giving me yet another example of proof that San Diego is on the cutting edge and the brighter days of our future are still ahead. Thank you all for including me today. Back to you, John.
Thank you, Mary Gloria. The Department of Energy's Office of Science is the largest supporter of basic energy research in the physical sciences in the United States. The Office of Science is responsible for 10 of the nation's national laboratories, many of which collaborate with General Atomics on a daily basis. Serving as the lead federal agency supporting research for energy production and security, the Office of Science is a key leader in the international ITER collaboration and has been an indispensable partner in the central solenoid fabrication process. We will now hear a few comments from Dr. Steve Binkley, Principal Deputy Director of the Office of Science.
Good morning, good afternoon, good evening. Here in the Office of Science, we enable and support world-changing science, including the design, fabrication, construction, and operation of first-of-a-kind science facilities with unmatched capabilities. Discovery, innovation, and competitiveness are at the heart of DOE science, and U.S. leadership is evident across many scientific areas, from high-performance computing to high-energy physics to one-of-a-kind light and neutron sources for scientific discovery. A defining strength of DOE science is the vitality of involving an interagency approach and the multiple partnerships, including national laboratories, universities, and industry at large. U.S. engagement in ITER is an excellent example of this approach. ITER will be a world-changing, world-leading science facility. As the first fusion facility specifically designed to produce a burning plasma, ITER will provide substantial opportunities for discovery. A burning plasma has never been observed on Earth before. ITER clearly fits our mission in the Office of Science to transform our understanding of nature and advance the energy, economic, and national security of the United States. Although ITER is being constructed in France, the International ITER facility will support the U.S. and the other ITER partners in achieving and understanding a high-power reactor-scale burning plasma, an essential step for fusion energy development. This celebration today of the successful manufacturing, testing, and shipment of the central solenoid magnet modules reminds us of the further value of ITER and other scientific investments to the United States. These investments not only yield profound discoveries, they also bolster our international competitiveness and readiness to innovate for the benefit of our nation. As you can see from the impressive manufacturing environment at the General Atomics Magnet Technology Center, The pursuit of discovery yields incredible rewards, not just for science or future energy, but also for our nation's industry and technological capabilities. On behalf of the Office of Science, I particularly want to express my appreciation to the entire U.S. ITER team, ITER Japan, who supplied the conductor for the central solenoid, the ITER organization, and all the industry and university partners who made this achievement possible. Thank you.
Under the direction of the Office of Science, the Office of Fusion Energy Science coordinates the national effort to build the science and technology basis necessary to develop fusion energy. As the largest federal government supporter of research in fusion energy, the Fusion Energy Science Program is the lead federal office for all things fusion. General Atomics is proud to have developed a positive, close working relationship with this office and its acting director, Jim Van Damme. At this point, we'd like to hear from Dr. Van Damme.
Greetings from the U.S. Department of Energy. My name is James Van Damme. I am the Associate Director in the DOE Office of Science for the Fusion Energy Sciences Program. Thank you very much for inviting me to speak at this special celebration. Today, we are celebrating several things. We are celebrating the potential of fusion energy to be a net zero carbon-free future source of clean energy, firm, dispatchable, safe, abundant energy for many generations while producing no greenhouse gases. This will transform the world. We are celebrating the International ITER project and the U.S. engagement in it as one of several international partners. ITER is a critical element of the U.S. strategy to advance our understanding of the fourth state of matter, plasma, as it relates to science and technology for fusion. From ITER, not only will we be able to observe a star on Earth, but we will also gain vital information about the behavior of high-performance 100 million degree plasma and the development of associated technologies that are critical for delivering practical fusion energy. We are celebrating a very exciting time in fusion research and development. Our understanding of plasmas has increased exponentially over the last 2 decades. Our predictive capabilities for plasmas have benefited from advances in simulation and modeling with modern high-performance computers. And we are prepared to benefit from our ITER investment and to advance our understanding of reactor-scale plasmas and ultimately a self-heated burning plasma. We are celebrating the successful manufacturing, testing, and shipment of central solenoid magnet module number 1. This is truly a major milestone in the U.S. ITER project. 6 of the central solenoid magnet modules being fabricated by General Atomics will be installed in the very center of the ITER tokamak. In fact, the central solenoid, which will be the world's largest ever pulsed electromagnet, is called the heartbeat of the ITER machine. Module number 1 was shipped from Poway, California to the port of Houston, and then transported by ship to the port of Marseille, France, last month, arriving on July 25. 5 more modules plus 1 spare module will follow. This outstanding achievement represents nearly 10 years of effort by the U.S. ITER Project Office, the ITER organization, and General Atomics. Many engineering and manufacturing challenges were resolved by the General Atomics, U.S. ITER, and ITER organization team to achieve this success. The General Atomics Magnet Technology Center team's high-quality performance in the fabrication and testing of these world-class magnet modules is most impressive. Each module is 7 feet high, 14 feet in diameter, and weighs 250,000 pounds, and is wound with 3.5 miles of superconductor cable. Yet the module fabrication requires precise alignment to 1 millimeter as the conductor is wound to the necessary diameter and height. This is a remarkable achievement. We are also celebrating the vital contribution of our Japanese partners who manufactured and delivered to General Atomics all the superconducting cable needed to build the central solenoid magnet modules. On May 3, 2018, 3 years ago, I attended the special ceremony for progress of ITER's central solenoid manufacturing and arrival of all ITER central solenoid conductors at the US from Japan. In attendance at this ceremony at General Atomics was a large and distinguished delegation from Japan. That was a memorable event. Regrettably, due to the pandemic, we cannot all be together again for today's equally memorable celebration. We acknowledge with sincere gratitude the partnership with our Japanese colleagues. The central solenoid will initiate and stabilize ITER's plasma. It is truly the heart of ITER's magnetic confinement of plasmas with the use of extremely strong magnetic fields. The 5-story tall, 1,000-ton central solenoid, consisting of 6 magnet modules, will induce 15 million amperes of electrical current in ITER's plasma to initiate each plasma pulse and provide vertical stability of the plasma. And to accomplish this, the central solenoid will attain a magnetic field strength of 13 Tesla, which is about 280,000 times stronger than the Earth's magnetic field. Central solenoid is one of the most technically challenging contributions to the ITER tokamak facility. The successful demonstration of both manufacturing and testing is a major achievement for the US program and for the International ITER project. The central solenoid is the only ITER magnet to undergo post-production testing that simulates the ITER operational environment at cryogenic temperatures of 4.5 degrees Kelvin, which is minus 452 degrees Fahrenheit, and power tested to 40,000 amperes. So on behalf of the Office of Fusion Energy Sciences, Office of Science, U.S. Department of Energy, I want to express sincere appreciation to the entire U.S. ITER team, including Oak Ridge National Laboratory, Princeton Plasma Physics Laboratory, and Savannah River National Laboratory, plus the international partners and experts who made this achievement possible. And in particular, let me highlight General Atomics for a great job, extremely well done. Thank you for this outstanding achievement.
As I have mentioned, fabricating the central solenoid is a monumental effort. From the significant challenges associated with modifying the building that we're in today and installing the machines behind me and throughout the facility, it's been a huge effort for the fabrication and testing of the central solenoid modules. Countless work hours went into planning and developing the 10-step fabrication process used in this facility to build each module. I am now pleased to show you a short video documenting the process for fabricating the central solenoid modules. And at the end, we'll recognize many of our local, national, and international partners that made this fabrication possible.
This is ITER, the largest science experiment ever built on Earth. This massive facility under construction in Cadarache, France, is being built by a global coalition of 35 countries. Its mission is to demonstrate the feasibility of fusion as an inexhaustible source of energy for the entire planet. At the heart of the ITER device will rest the central solenoid. It will be the largest pulsed superconducting magnet ever built. It will drive more than 15 million amperes of current into the fusion plasma to heat and stabilize it. The 6 modules of the solenoid are being fabricated at this facility in San Diego by General Atomics, under the direction of the U.S. ITER Project Office. GA is a recognized supplier of high-tech hardware with decades of experience in fusion research. Here at GA's Magnet Technology Center, a skilled team of technicians and engineers are hard at work producing the 59 feet tall central solenoid, along with a 7th module that will serve as a spare. Inside the facility is a highly specialized purpose-built production line for fabricating and testing the central solenoid modules. When the team at GA took on the central solenoid project, they faced a series of challenges, starting with modifying the facility to accommodate the 250,000-pound modules. The standard floors were replaced with 24 inches of concrete to support that weight, while cranes and other specialized infrastructure were added to support the manufacturing process. The core challenge was how to build the machinery and processes needed to form 3.6 miles of steel-jacketed conductor into a 40-layer module with 14 turns per layer. Years of careful engineering and design efforts, in close collaboration with experts across the globe, yielded a 10-step fabrication process that pairs the latest technology with highly trained technicians to produce the modules. The production of a module requires 2 years, followed by months of testing. The process begins with delivery of spools of conductor from Japan, part of that country's in-kind contribution to ITER. One of the earliest and most complex steps involves the precise winding of the conductor to create the turns of each module. The conductor must first be almost perfectly straightened from the spool, then bent by rollers exerting immense force to shape the individual turns into precise radii. Because the conductor lengths are limited to 900 meters, modules cannot be made from one continuous piece of conductor, but are instead made from 7 sections that must be joined together. The team has developed an innovative process to bring together lengths of conductor into a seamless joint. First, the stainless steel jacket is machined away from the 864-strand cable of niobium-3 tin and copper wires. The strands of the cable have to be spliced together before a highly skilled operator uses a computer-controlled process to weld the stainless steel jacket over the splice. To create its immense magnetic field, 50,000 amperes of current must be driven in the central solenoid module. For this, the module must be superconducting. However, superconducting material is brittle and cannot be bent. This means conductor wires start fabrication in metallic form before being converted into superconducting ceramic-like material by a 5-week heat treatment process. During the heat treatment, the module is heated at temperatures over 1,000 degrees Fahrenheit for more than 14 days, after which it is slowly cooled for a week to complete the process. To keep the electrical current in the conductor, every inch of the steel-jacketed superconductor must be wrapped with 6 layers of electrically insulating tape, a total of 180 miles per module. To protect the now brittle superconducting material from damage, GA built a massive machine to lift the 250,000-pound modules off the ground. Each turn is then separately released to stretch them like a slinky, making room to apply the 6 layers of tape. But the team is still not done. They must wrap the surfaces of each module in additional layers of insulation, ensuring the coil is electrically protected from ITER, and ITER is protected from the coil. The next challenge is to convert the 560 turns of the coil into a monolithic structure to withstand the immense forces it will be subjected to during the operation at the center of the ITER device. With a mold placed around the coil, all the air is sucked out and replaced by 900 gallons of resin, which completely fills all spaces in the module. The resin is then cured at 260 degrees Fahrenheit. Once the module completes fabrication, one final step remains, and this one is perhaps the most grueling. The magnet must be tested in ITER-like conditions to ensure it will function as planned. It is placed in a special test chamber where it is cooled in a nearly complete vacuum to 4 degrees Kelvin, or minus 460 degrees Fahrenheit. After months of intense tests, the module is certified ready to take its place in the heart of ITER. The first central solenoid module finished testing in 2020, paving the way for remaining modules to follow to the ITER site over the next 2 years. The module is placed on a shipping fixture, boxed up, and trucked to a port in Texas, where it's loaded onto a ship for its journey to France and the ITER site. Once all the modules are stacked and surrounded by supporting structure, they'll be lowered into the center of the massive ITER tokamak, forming the beating heart of this historic effort to fulfill the promise of fusion, the promise of unlimited energy for all of future humanity.
So I hope from that video you got a sense of some of the fabrication efforts that go on in this facility and many of the individuals who participate regularly on a daily basis. Continuously throughout COVID, we've had almost zero interruption to our manufacturing process. So it's an attribution to the team and their dedication. The ITER project has been a literal worldwide effort, with systems and components being delivered from around the globe to the ITER site in southern France. It is now my pleasure to play a greeting from Dr. Bernard Vigo, Director General of the ITER project, who is responsible for the coordination of this immense international effort. However, as you listen to his words, Dr. Vigo shares many images of the progress at the ITER site, and it'd be very good to see the immense progress that they've made there.
Greeting to all of you from the ITER work site here in Provence, France. Even though I regret I am obliged to participate in this event remotely, the celebration of completion and shipping of Central Solenoid first module, it is a really great pleasure and honor to be able to celebrate with you this critical milestone in fusion manufacturing and the US contribution to the ITER project. None of this would be possible without the sustained support of multiple parties, and I would like to recognize a few of them. The support of the United States Department of Energy, from our close colleague in fusion energy science and the Office of Science to the Office of the Secretary of Energy, has been absolutely vital in demonstrating US support for ITER. The same has been true for the support we have received from the US State Department and from the Office of Management and Budget. I would like also to express my gratitude to the members and committees of the US Congress that have taken a strong interest in the ITER project since the beginning of the ITER project. The House Science Committee, the Senate Authorization Committee, and the House and Senate Appropriation Committees. Over the past 6 years, we have found support for ITER at every level, at every stage. Thank you. Today, this celebration is about a specific achievement, the completion and shipment of a specific component for a specific project. But it is also a recognition of a much larger global priority. That is, the world urgently needs expanded and new forms of carbon-free energy, including hydrogen fusion. Fusion holds the unique promise of providing safe, environmentally friendly, concentrated baseload energy as a true replacement for fossil fuels, with a globally available and virtually unlimited supply of fuels for millions of years. We know that achieving practical fusion energy will require multiple advancements, including ITER's demonstration of self-heating plasma, what we call a burning plasma, and industrial-scale fusion power. The continued commitment of all ITER members, the European Union as host, plus China, India, Japan, Korea, Russia, and the United States of America, is essential to ITER's success. For each ITER member, the completion of specialty component for the ITER tokamak, as well as its support system, has major impact on industrial capability, capacity, and technology. Industry innovation is really critical for hydrogen fusion. The central solenoid magnet is an excellent example of project cooperation and performance. 3.5 miles of superconducting cable in conductors for the central solenoids were provided to the US by ITER Japan. The design of the magnet plus the resolution of many challenges along the way engaged international experts across the project in order to achieve a thoroughly tested final component that will meet ITER demanding performance requirements. With this achievement, US deliveries for the whole central solenoid, the beating heart of ITER, are on track for installation in the ITER tokamak starting in 2023. Here at the ITER site, the international project continued to make impressive progress with the arrival and installation of the first magnet. We have already received indeed on ITER site and fully qualified 9 of the total 30 superconducting magnets, as well as the ongoing pre-assembling of first vacuum vessel sectors. We hope you will be able soon to visit us to see this progress firsthand. I would like to close this speech with a sincere personal thank you on behalf of the entire ITER project to a close colleague at US ITER at Oak Ridge National Laboratory, and to their industrial supplier at General Atomics for their constant collaboration and for this magnificent achievement. The celebration today of a first-of-a-kind superconducting central solenoid modules is first evidence of US commitment to ITER and to advancing to fusion energy across all sectors. You deserve our deepest gratitude and congratulations. Thank you.
Thank you, Dr. Vigo. I hope you appreciated as much as I did seeing the progress on the ITER site. I'm always impressed when I see the new buildings and now filled with equipment. I can remember my first visit to the ITER site in 2007 when there's nothing but forest, not even yet cut down the trees to make way for the ITER site. So to see it today is quite an incredible accomplishment. On the topic of international partnerships, General Atomics has a long history of fusion collaborations with Japan. Starting with Doublet 3 and then D3D, Japan has played a critical role in fusion at General Atomics. The central solenoid is no exception. As you've heard, the building block of each of 7 modules is the 3.5 miles of conductor provided by Japan. All told, General Atomics has received 54 spools of conductors for the fabrication of the modules. The spools arrived exactly as specified and have been utilized without issues. As evidence of our close collaboration, we are deeply honored now to hear from Dr. Hiroki Matsuo, Senior Deputy Minister of Education, Culture, Sports, and Science and Technology.
Good morning, everyone. I'm Matsuo Hiroki, Senior Deputy Minister of MEXT and the head of Japanese delegation for the ITER Council. Today, I'm delighted to express a few words of congratulation. In April of this year, Japan-US Climate Partnership on decarbonization was agreed at the summit meeting between President Biden and Prime Minister Suga. New policies for carbon neutrality have been adopted, such as the return of the U.S. to the Paris Agreement by President Biden and the declaration of carbon neutral by 2050 by Prime Minister Suga. Under these circumstances, I feel that interest in hydrogen fusion energy is growing worldwide. For example, the concept of U.S. fusion pilot plant announced by the FISAC in February of this year is also attracting attention in Japan. It is at this historic moment that the celebration ceremony of the shipment of the first ITER CS module is taking place today. I'd like to express my warmest congratulations and pay tribute to the Department of Energy, General Atomics, and all the other members working together in the US and Japan. For me, as a member of government of Japan, I'm proud that the CS module was produced with the conductors made in Japan and winding and assembling work in the US. This CS module is a symbol of US-Japan cooperation and the high level of hydrogen fusion technology in the US and Japan. Assembling in installation activities at the ITER site are well underway. At the same time, discussion on the operation phase began. We hope to continue working closely with the U.S. to contribute to the success of the ITER project during the operation phase as well as construction phase. The U.S. and Japan are important partners in the field of hydrogen fusion, including ITER. We have also strengthened our cooperation through the CCFE, which celebrated its 14th anniversary last year. In closing, I hope that U.S. and Japan cooperation will expand in the future. Thank you very much.
In addition to the close collaboration we have with the government of Japan, we have also formed close relationships in the research sector. Next, we will hear from Toshihiro Hirano, President of Japan's National Institutes for Quantum and Radiologic Science and Technology. Established in 2016, QST promotes research and development into quantum science and technology. QST is also the home of the Fusion Directorate in Japan. Dr. Toshihiro Hirano.
Hello, everyone. I'm Toshihiro Hirano, President of QST, the domestic agency of Japan for the ITER project. Thank you for the opportunity to be part of such an important and momentous ceremony. I'm sorry I cannot be there in person, but we'll have to make do with a video message. First, I'd like to congratulate General Atomics, U.S. Domestic Agency, U.S. Department of Energy, and other U.S. colleagues for successfully delivering the first module of the central solenoid to France and steadily manufacturing subsequent modules. The central solenoid is of paramount importance to the ITER project, and its manufacture is no easy task. 3 years ago, it was with great pleasure that Japan could pass the central solenoid baton to the United States. QST was able to successfully manufacture all 49 of the superconducting conductors for the central solenoid, with the United States playing an important supporting role after the Great East Japan earthquake in March of 2011. Then, just as now, a ceremony was held in the U.S. to celebrate the completion of the conductors. Thank you for helping us mark that occasion. Now, at the present time, the ITER project is facing challenges due to the impact of COVID-19. But despite these difficulties, the United States has made steady progress in the manufacture of the central solenoid, which in my opinion shows a strong commitment to development hydrogen fusion in the United States. The progress made is also thanks to the technological abilities of the United States. The innovative conductor joint design and winding technology to accurately form conductors in coils will greatly contribute to the progress of hydrogen fusion development in the future. As construction of ITER kicks into gear, I'm confident that the American people, with their strong will and technological spirit, will have no difficulties in overcoming any obstacles they may encounter. There is absolutely no doubt in my mind that we'll be able to construct ITER. In closing, let me express my gratitude once again for the opportunity to speak with you today to celebrate everyone's effort. Thank you for your attention. August 10th, 2021, Toshihiro Hirano, President of QST.
Lastly, we are privileged to hear from Dr. Katherine McCarthy, Associate Laboratory Director at Oak Ridge National Lab. She is the director of the U.S. ITER Project Office and leads the U.S. effort in ITER. Dr. McCarthy?
We have been honored today to have so many esteemed colleagues join us to celebrate this major milestone. I'm grateful for the dedication of the U.S. ITER team, the ITER organization, and General Atomics team to reach this achievement for ITER. We all work together to make this milestone possible. Ultimately, these achievements show us that we can not only have incredible ideas, like building a burning plasma research facility, but we can turn those ideas into reality. By undertaking the practical engineering challenge of fabricating the central solenoid, we advance our readiness not only to benefit from ITER, but also to design and build components, systems, and future reactors that can bring usable fusion energy closer to reality. Solving ITER-scale challenges and delivering precision components advances U.S. science, engineering, manufacturing, and ultimately the readiness for the next steps in fusion. On behalf of U.S. ITER and Oak Ridge National Laboratory, I particularly want to express my appreciation to the entire U.S. ITER team, and that includes the engineers, magnet experts, designers, analysts, procurement and project control specialists, and the administrative staff who helped General Atomics make this achievement possible. Thank you for joining us today.
We have heard today from many distinguished guests and key stakeholders of the ITER project. These speakers, each of whom has been a leader and an advocate in their own right for the ITER experiment, have underscored the importance of this project. While these individuals come from a wide range of backgrounds, they speak in one voice when it comes to realizing the promise of fusion energy. This is a global effort, and partner nations around the world are contributing, from the smallest of components to big first-of-a-kind technology such as the central solenoid. I think back to my first visit to this building. It was nothing but an empty warehouse. We made major modifications to nearly every inch of the building, including pouring the 2 feet of concrete beneath you today. I think it is very fitting to close today by recognizing and thanking the members of the ITER CS team. First, the magnet teams at US ITER, Project Office, and the ITER organization, who have been instrumental in making this effort. They have been true partners in reaching the milestone we celebrate today. Lastly, but in no way least, I would like to thank and commend the General Atomics team. In my opinion, it is without equal, and I am constantly impressed with them. I find their technical capabilities superior and their efforts tireless. But as important as those are, I believe the true secret of our success is teamwork. I have never experienced a group of people working together to the degree I have had the privilege and experience in working within this project. It has been a lot of hard work, but this team has made it a great experience and one I will never forget. Today's ceremony was a celebration of the technology we created, but more importantly, it was a thank you to those people who worked together to create it. Thank you all for coming, whether in person or remote, for your participation today and making this a true celebration of an amazing accomplishment. Thank you very much for coming.
Down the path alongside the lake, a tender-hearted woman saw a poor half-frozen snake. His pretty colored skin had been all frosted with the dew. Oh, well, she cried, I'll take